The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so back into the origin. Natural selection, of course, is the key mechanism that Darwin is bringing out here. And we do have to keep in mind, we don't have time to go into his work, but Alfred Wallace was the co-discoverer, natural selection. He was a man who had traveled widely, and he had he collected specimens. He did all sorts of things in his travels. And he, in his travels in Indonesia in 1858, he hit upon the concept of selection, a selection process that took place as a kind of a filtering process, if you will. I mean, selection, in artificial selection, somebody actually does the selection, right? The person who owns the sheep herd or whatever, selects the sheep. So there's a selection process. How is natural selection different? Natural selection is a kind of filtering process, if you will. That is, if there are two organisms and one is slightly more able to survive under certain kinds of pressure and manages to survive and breed, it's been naturally selected. So, but there wasn't really an agent selecting in this context. And natural selection takes place in a whole variety of ways. There are lots and lots of different ways in which things can get filtered out. And some organisms live perfectly well and die in old age, but just never manage to breed. I mean, they just don't get access to the partners, and therefore they have no offspring. So this is another factor. So the concept of selection here is sort of the way Darwin uses it is a metaphor for filtering process. And Wallace hit upon the same idea. In the handout I sent you, I included his Ternate essay. I don't know if anybody's here. I mean, it sort of gives his statement. This is the statement that Charles Darwin received in the mail. And of course, Darwin went into some kind of, I don't know if panic is a word, but he certainly wanted to, he was a very honorable man, so he felt that maybe he should just forward Wallace's essay to the Linnaean Society and just give Wallace credit. But he had been working on the same theory for years. He had the concepts all worked out and so forth, and he'd even discussed them with colleagues. So it was decided by his colleague Hooker that they should really, Wallace and Darwin should announce their theory together, which they ended up doing. And so, and Wallace, it turned out, was a very good sport about this. I mean, he definitely saw Darwin as the sort of comprehensive thinker in this area. And Darwin was cordial to Wallace. So, in some sense, it's always mentioned that natural selection was co-discovered. I mean, there are lots and lots of ins and outs of it if you really want to study it, but in general, that's the way it happened. Wallace was a naturalist, definitely raised in a more modest background, educational background than Darwin. Didn't go to Cambridge, things of that sort. But he had a lot of natural talent. And he was a type of person in the 19th century who liked to travel. Or at least, I don't know, if he didn't like to travel, he certainly did a lot of it. And he wrote books about his travel. And one of his very famous books is The Malay Archipelago, which is an absolutely wonderful book. Came out 10 years after the origin. But it's just his account on his travels in Malaysia and his, some of his ideas about evolution, and also about just the people he met. So, okay, I don't know why his picture got blacked out here. All right, so back to chapter 3, which we were just kind of getting into at the end of the last class. Darwin mentions his term natural selection, and he says, I've called this principle by which each slight variation, if useful, is preserved by the term natural selection in order to mark its relation to man's power of selection. We have seen that man by selection can certainly produce great results and can adapt organic means to his own uses through the accumulation of slight but useful variations given to him by the hand of nature. Some of this language always reminds me of Adam Smith. You know, these hands and, you know, these economies and all. This word keeps coming up, and I've never decided for sure whether Darwin was thinking of Smith or not. But certainly the language kind of reflects some of this large system thinking. The hand of nature here. But natural selection, as we shall see hereafter, as we shall hereafter see, is a power incessantly ready for action, and is as immeasurably superior to man's feeble efforts as the works of nature are to works of art. How about that? What's he talking about here? How is natural selection so immeasurably superior to artificial selection?
There's a quote from chapter 5 that I think you were alluding to, is that natural selection cannot possibly produce any modification in any one species exclusively for the good of another species, though throughout nature one species incessantly takes advantage of and profits by the structure of another. So the difference between artificial selection and natural selection is that in natural selection, the chicken's not getting bigger for someone else's needs. It's doing because it's helping itself to be able to, or not helping, it's, you know, as a result it's being able to survive better. Whereas in artificial selection, every change that's made in the chicken is really only a benefit to us because the chicken doesn't get to.
Yeah, that's the crucial distinction. In artificial selection, we bend these forms to our purposes. So humans are interacting with these natural forms in order to shape them and make them more supportive of what humans want. So this is a pretty amazing process when you think about it. When you sit down and think about, you know, the domestication and artificial selection, what it's produced. It's humans taking the natural world, and to the extent that it offers opportunities through generations, bringing some of those possibilities into closer relationship and closer support of human ends. Why were dogs domesticated? I don't know. We have lots of theories. Maybe they provided an early warning system, or, you know, maybe they helped people hunt. There are lots of things that dogs did. And they are cute, yes, and that's another thing they do. We breed them to look beautiful. You know, think of the dog shows. You know, all these phenomenal breeds. I mean, you just look at a dog show and you see these incredible breeds. They look, some of them look really bizarre. They're so tremendously adapted. Yeah.
Then you have breeds like the pug, where they've bred it so much that it can't even like breathe anymore.
Yeah. So, and that goes back to the question: is this good for the dog, or is this good for And yeah, we reach, the stages where certain animals can't function naturally. Many of these domesticated forms, as I was saying last class, if released to nature, would perish. They become, food for other more capable and better naturally selected organisms. So we not only breed, but we also, in some sense, sequester and protect. We protect that livestock. Those sheep out there, you have to have a shepherd out there and some sheepdogs to keep the wolves at bay or whatever. And because, they can't, these domestic sheep can't protect themselves. So, same thing with plants. I mean, plants are probably even a much more profound area of domestication, because plants really gave rise to all kinds of possibilities for people shifting from hunter-gatherer to agricultural societies. Created more stability. But, those plants had to be planted, had to be maintained, and harvested and reseeded and so on and so forth. They needed a lot of attention. And it was worth humans' time to do that, because they got in return a much greater production, more resources, and so forth. So domestication is a massive story for humans, and it made possible. It's the basis of civilization in many ways. Okay, so now we come to natural selection. And as Darwin says, a power incessantly ready for action. It doesn't just do it at, breeding time. In the natural world, selection never stops. It's just a constant process. And what about these forms that are naturally selected? Do they revert back to aboriginal stocks? Are they likely to? That is, to ancestral forms?
They're not likely to.
No, because they've already outcompeted their ancestral forms. So the idea of they're going to revert back to some kind of more original form is just not the way it works. It moves forward. That doesn't mean that certain forms won't become highly complicated and become more simple and adapt to various circumstances. But this is not. This is a much more powerful form of selection. It changes features that range right across all the. The potential subject matter for natural selection is everything. The sensorium, the senses, chemistry of the body, nervous system. All of it is up for change. Simply because all of it is potentially changeable through random variation. We understand more now what that is all about, as we understand the genetic basis of it. Darwin was not working from that direction. It's amazing how far he got without having these micro theories. But he knew that there was some kind of material basis for this. He just didn't really know enough chemistry and microbiology to know what it was. But he pretty much nailed that there was something going on at the physical level. Okay. All right, so the struggle for existence is definitely something that is introduced in a very dramatic way in chapter 3. And, you know, it's pretty brutal what he's talking about. He says, I mean, he doesn't pull any punches here. He says, I quote him, "Nothing is easier than to admit in words the truth of the universal struggle for life, or more difficult, at least I have found it so, than constantly to bear this conclusion in mind. I am convinced that the whole economy of nature, with every fact on distribution, rarity, abundance, extinction, and variation, will be dimly seen or quite misunderstood. We behold the face of nature bright with gladness." Think of Wordsworth here. "We often see superabundance of food. We do not see or we forget that the birds which are idly singing around us mostly live on insects or seeds and are thus constantly destroying life. Or we forget how largely these songsters or their eggs or their nestlings are destroyed by birds and beasts of prey. We do not always bear in mind that though food may now be superabundant, if it is not so at all seasons of each recurring year." So, you know, this underlying, you know, struggle for resources. And he mentions it's the doctrine of Malthus and so on. He brings up Malthus a couple times here. This is one of Audubon's watercolors from his Birds of America. And I always used to look at this watercolor. I mean, we've all seen Audubon. I used to say, "Oh, those beautiful jays there." And when I was, you know, it took me some time before I realized what they were doing. They're robbing a bird's nest. Jays are pretty nervy birds. I don't know if you know about jays, but they're, you know, they're very good scavengers and they're very aggressive birds. And so you see this beauty in Audubon's painting. And this is before Darwin. Audubon didn't have to read Darwin to come up with this quintessential piece of Americana. So you see this process. Life goes on. This is how it is supported. Okay, so this is the underlying theme of this chapter. I continue with his section here. "There is no exception to the rule that every organic being naturally increases at so high a rate that if not destroyed, the earth would soon be covered by the progeny of a single pair. Linnaeus has calculated that if an annual plant produced only 2 seeds, and there is no plant so unproductive as this, and their seedlings next year produce 2, and so on, then in 20 years there would be 1,000,000 plants. The elephant is reckoned to be the slowest breeder of all known animals, and I have taken some pains to estimate its probable minimum rate of natural increase. It will be under the mark to assume that it breeds when 30 years old and goes on breeding till 90 years old, bringing forth 3 pair of young in this interval. Just 3 pair of young in this interval. If this be so, at the end of the 5th century, there would be alive 15 million elephants descended from the first pair. So basically, you know, how fast do environments get populated? In geological terms, instantaneously. I mean, you know, this is nothing compared to Lyell's geology. I mean, you know, the overproductivity of the natural world is just absolutely stunning. And of course, this is something that, you know, we don't normally think too much about, or we don't see. I mean, a lot of Darwin's not just talking about organisms out there ripping each other apart. You know, there are a lot of different ways in which these struggles take place. And struggle, in some ways, it may not be the best word, because, you know, I don't think that eating a seed is necessarily something that makes you get an image of struggle in your mind. So, but you know, the fact is that there's just this vast potential for life. an amazing development. Okay, so so in what ways is this similar to Malthus, and how is it different? Chris?
It's also proposing the unchecked growth of organisms in population. In that way, it's similar to Malthus.
Okay. It is, yeah. It's certainly the Malthusian principle of rapid geometrical increase in populations is core here, is a core part of this. How is it different? Yeah, David.
Well, in Malthus, there's it ends sort of on a lighter note, saying with an increased population, there's an increased variation, and hence that leads to invention. But I don't really see that as much here.
Okay.
Especially in natural selection, there would just be greater adaptation to the environment, and hence greater struggle.
Okay.
Competition.
Okay, that's you bring up a really interesting point. So Darwin's talking about the natural world, isn't he? What world is Malthus interested in? The human social world. So, I mean, he's saying, yeah, humans are biological organisms, and they breed and they have offspring and so on, and they try to produce the resources needed to support the population, and they can keep up to it to a certain extent, but they can in no way produce enough to endlessly support the geometric increase in population. But he's not really, I mean, he talks about the natural world and humans as part of the natural world in some sense, but in Malthus is not the biologist, there's not a biologist's mind there. Much more a theologian, statistician, cleric, very, very savvy thinker, social scientist is what he is. Darwin's a biologist. I mean, he thinks in very systematic ways, and he doesn't even try to deal with, he just puts humans aside because he knows, I mean, later he comes back to this question, but in some ways humans are a special case. They are the exception. The world that Darwin is talking about it's just the natural world. And he will later come back to humans when he writes his Descent of Man. But he does say at the end of the origin that, light will be thrown on the origins of humans too. But that's not what he's dealing with here. He's just dealing with the natural world. His chapter on instinct really treats instinct as an organ. Instinct is highly specific. It is inherited through the generations. It is a phenomenon that can change. There are variations in instinct that produce better and better versions that enable the organism to survive better. It's a material thing. But as you say, it's hard to think of it that way because instinct is, we think of it as mental. We think of it as something that, is in the mind, and, we kind of think unclearly about it mostly because, we think, oh, why did I do that, or why am I, it's like, we encounter instinct mentally. Yeah.
Do you think, like in humans, we have like our fight or flight response, which is very instinctual and very based in the body. It's easy to think that if an organism didn't have that response, they would more easily be killed off than organisms that did.
Yeah. It's got to, any change, Darwin says, that is not beneficial to the individual If somebody can show me such an example, my entire theory falls to the ground. So instinct in Darwin's system is beneficial. And by beneficial, we mean it gives the organism a greater degree of adaptation to its environment. And there are certain species, forms, whole families, genera, families, classes of organisms that pretty much run on instinct. I mean, we're thinking, of course, of insects and things of that sort. Don't need a lot of rational. I mean, if your instincts are really well adapted, and there are lots of you, and you know, you can run on pretty much pure instinct or something like it. Whereas humans have kind of, you know, yeah, they have the instinct, and that's incredibly important. I mean, there are a lot of things that happen in humans that is instinctual. You know, families are bound together through, you know, paternal, maternal instincts. I mean, there are all sorts of content that is derived from instinctual, it has an instinctual basis. But humans have also, you know, we've just come through this enlightenment where Smith and Hume and, you know, all these people are talking about the powers of the brain and the great, you know, this great human thinking entity that can do wonders. So now here comes in Darwin with, boom, instinct. It's like, oh, this is kind of a, this is a jolt for people who thought that human behavior is primarily rational. And now we're thinking, wow, it's got instinctual we actually have, you know, there are instincts in us. And we have to assume that they're in there because they've been beneficial. However, at certain points, we begin to wonder when we encounter something like Thomas Malthus, because the instinct's there. Human instinct isn't always beneficial to the individual. It drives them, in Malthus's sense of things, to, you know, all kinds of bad actions that a more rational person would, you know, reject. Okay, so yeah, we'll come back to instinct, but it's a very big part of this. In the same chapter 3, Darwin talks about the web of complex relations. And this is the fact that all life is intimately integrated and connected to other forms of life. That there is a kind of dependency in life that makes organisms that takes in which a change in one organism will have an effect on a whole variety of other organisms, because organisms just aren't individual entities. A tremendously important idea in the origin, that all life is interconnected. And if some species disappears, it's probably because some other species has pushed it out. You know, species are constantly morphing and changing, and you know what we're getting is this kind of mass of change and complex interaction. And Darwin gives some specific examples, but one of the main quotes here is, lighten any check. This is the natural selection. Lighten any check, mitigate the destruction ever so little, and the number of species will almost instantaneously increase to any amount. The face of nature may be compared to the yielding surface with 10,000 sharp wedges, packed close together and driven inwards by incessant blows. That's a pretty violent metaphor. Sometimes one wedge being struck and then another with greater force. And can you? This is a pretty dramatic picture of nature, isn't it? He's trying to give an illustration where he gives the relationship of bees and mice and honey. What's the relationship? Does anybody recall that? Why is there more, well, he gets this from one of his observers. Somebody tells him, you know, there's a lot more honey around the village than when you go further out away from the village. Why are there more bees' nests and honey closer to just the outskirts of the village? Anybody remember, Devin?
I mean, I was.
Okay.
Keep going.
This was in on page 73. But what eats the bees? Mice eat bees, the field mice, and they eat a lot of them. What eats mice? Well, cats like to eat mice, and you know, around the villages where there are lots of cats, the mouse population is kept down. So that allows the bee population to thrive a little bit better. So there just, as a result of that, happens to be more honey in the proximity of villages because bees make honey. So it's just an effort on his part. He has a whole series of different kinds of examples of, you know, how there are certain types of cattle in South America and Paraguay, he says, that they just can't breed them unless they breed them in very close oversight of the ranch, because when the young are born, there's a little tiny fly that lays its egg in the navel of and it will inevitably destroy the newborn, and therefore they just can't raise below a certain latitude. You just can't raise those species of cattle. So the point he's trying to make is that, you know, nature, we don't realize how interrelated and interconnected a system, the natural system, actually is. We don't really appreciate it. And through the evolutionary lens, the understanding through evolution, we can see through these mechanisms, these forces, how closely interconnected all these different species are as they compete for spaces in nature. We call them niches now. Darwin uses the word space over and over again for, you know, a place in nature. Yeah, Devin.
To get to your question of how Darwin views nature,
Yeah.
I've always kind of visualized nature as this kind of taut, stretchable fabric, and that, you know, with each of the links and the meshes being a different species, that, you know, if you have an increase in population, the fabric gets more taut, and the other, you know, regions around it go down or up as a result of that. And unfortunately, if the balance gets too far out of play and you push one population too high, the fabric will tear, and because it's already taut, you can actually cause a cataclysmic change that'll rip the entire fabric in two. So that really emphasizes the importance of that kind of dependency. But I think, as you were getting at too, it's also important to notice that it's a mutual dependency. Like, you know, for example, the classic predator-prey, the lynx and the rabbit, you know, because even if the lynx population goes down, the rabbits explode and they die off, not from the lynx, but from the lack of food in the environment, because they're competing for limited resources. So.
Yeah. So there's this kind of interdependency. And these are modern studies. I've given you a paper here. You can check it out if you want. People actually study. This is a modern subject of study, of ecological study of these patterns, these webs of relationships. And they're highly, highly complicated. And people chart them out and figure out, you know, what's happening to the populations in certain locations. because if you somehow artificially end up removing a species, and humans can do that, you know, we can overfish, we do all. You know, the loss of a species, when you begin to think of the complex web of really, you know, we don't really know what the impact of the loss of a species actually is. There could be tremendous collapse. It could also mean that something else fills its space. But biologists today are very interested in these web relationships and study them at great precision to try to get an understanding of how the connections, and it's really coming straight out of, I mean, these are ideas that Darwin brought forward in his theory. So what we see here is a kind of a whole sea change in the sort of way in which we think about nature, and thinking about it much more precisely in terms of the dynamics of its entities and the spaces that are available and the changing forms and the relationship between the forms. It's a much more physical concept of nature. And Darwin is really just pushing this to a tremendous extent in this book. It's just, I mean, everybody likes to say, and I totally agree, that Darwin didn't do this all by himself, but the power of this book in driving home this idea of the physical complexity and the fact that this complexity is governed by natural forces and laws, it's just astounding. It's a tremendous shift. So this is a very physical view of nature, a very material view of nature. You know, there's a fundamental materialism in Darwin. I mean, you know, this is basically a very powerful physical theory. So he says, you know, nature can act on every internal organ, on every shade of constitutional difference, on the whole machinery of life. Man selects only for his own good, nature only for that of the being in which she tends. So we've seen this. Maybe said that natural selection is daily and hourly scrutinizing. So even in this illustration, so there have been lots of studies after Darwin of the way in which character is displaced through periods of drought and so forth, where tremendous pressure is put on local populations. And when these pressures are exerted on these populations, something has to give. And the species that don't have quite the adaptation to the environment are going to be the ones that get outcompeted. And through this process, certain features and changes in the native populations can shift. And those organisms will have a superior opportunity to have offspring and breed down through generations, so that you can get this phenomenon that is sometimes called character shift. The other thing I wanted to mention about his view of nature is it's very numerical. It's really about just it's statistical. You know, what is a species? We can give some kind of definition, but a species is whatever seems to survive and breed in groups. It's kind of it's a very indefinite concept. We tend to think, oh yeah, there's this, because we think of our species sometimes through the metaphor of our domestic forms, and say, oh, there's this species of animal that looks this way and another species, so we have this nice divided sense of species. But in Darwin, he struggles with the concept of species. Is there such a thing, or how do we define it? It's basically breeding populations. And they're not so distinct that they don't necessarily cross over. And there are a whole range of phenomena like subspecies incipient species, things that seem to be forming, but we can't tell quite yet. So I think we have much better tools today to come up with some of these ideas, because we have a basis for actually seeing material differences. Okay. Speciation, a very, very complicated process. I gave you a little primer in there if you're really interested in speciation. I mean, it's a whole field of study, but there are generally a series of patterns that take place. The one that Darwin seems to favor the most is the notion of geographic separation. When organisms get separated geographically, they don't rebreed back into the parent population. That allows for a kind of independence of breeding. But we have several different versions here. I just took this out of entry on Google. But if you're interested, but you can see the problems here partially. Just isolation. Sometimes isolation in a adjacent habitat, and sometimes some kind of isolation within a native population. And the mechanisms of these can be quite complex. He mentions in this same chapter special cases. So sexual selection, what is this? These are special cases of natural selection. Jake.
Where a creature has a particular trait that is attractive to potential mates, that one will get selected more often than another one because of that trait.
Okay. This is so yeah. This is a special case and a weaker form of selection. As he said, this depends not on a struggle for existence, but on a struggle between males for possession of the females. There are actually a number of other mechanisms too, but he's just mentioning this one. The result is not death to the unsuccessful competitor, but few or no offspring. Sexual selection is therefore less rigorous than natural selection. The war is perhaps severest between the males of polygamous animals. And these seem oftenest provided with special weapons. Great big antlers of the huge deer, or the big tusks of the walrus, or whatever. I can see no good reason to doubt that female birds, by selecting during thousands of generations the most melodious of beautiful males, according to their standard of beauty, might produce a marked effect. The bird of Paradis was one of the famous examples. Here in sexual selection, it's the female that's doing the selecting. It's the male that's presenting itself, and then you often see this kind of nondescript little female and goes up and it looks and says, moves on to some other. And of course, the problem is some of these secondary characteristics that these males develop actually expose them in greater degree, or hamper their movement, or do all sorts of things. And so I suppose in some ways they are seen, it must be so, as more fit because they have the excess capacity. I mean, the resources to build whatever the expression is that is being selected for can be tremendous. And they may not be beneficial to the organism at a certain stage in survival and just basically surviving. Evan.
I was actually really confused about this when I read about this, because at one point in chapter 5 he says, natural selection will never produce in any being anything injurious to itself, for natural selection acts solely by and for the good of each. And like for example, with this bird of paradise,
Yeah.
or like the
Yeah.
caribou or elk we talked about before,
Yeah.
I don't know if that's actually true.
Yeah.
So in that case, is it the species that keeps trying to populate, or is it like the traits? In other words, I'm kind of alluding to like the selfish gene sort of idea. Is it,
Yeah.
is it really the organism that's benefiting from all of this, or is it the continuation and reproduction of this same trait, whatever it is?
Well, it would part of the fact of being beneficial to the individual is getting selected to mate, because that allows you to get your genetics into the next generation. So that's the name of the game. The name of the game is to breed into the next generation and to transmit your genes, so to speak.
Really, for the good of you really means how can I have my traits proliferate
Yeah.
as much as possible?
Yeah.
Okay.
That's where it's so. But it's a game of chance too. Oh, are you going to be more beautiful and bigger and fluffy than the next male that comes along? So there's a kind of there's a risk element there. But it seems to be driven. I guess we can come back to good old instinct here. I mean, instinct is somehow driving these organisms to these extent. And as far as the fitness of these individuals, at least theoretically, if they have, as I said, the excess capacity to not just survive and get enough to eat, but to develop this incredible plumage and everything, they must have a pretty nifty, set of genes. So I suppose there's some kind of, at some level, there's a evaluation taking place. And I don't know anything more about it than that, because I'm sure there are definite specific mechanisms and instincts that could be worked up. The other special case that Darwin talks about, and has turned out to be very controversial, is group selection. Here he says, in social animals, it will adapt the structure to natural selection of each individual for the benefit of the community. And this comes back to your point, how is this benefiting that individual? Can the benefit to the community supplant the benefit to the individual? And this isn't a totally settled debate even today. And there are many people who say, this is just not a good theory. And there are many other explanations for it. But Darwin's view is for the benefit of the community. If each in consequence profits by the selected change, what natural selection cannot do is to modify the structure of one species without giving it any advantage for the good of another species. And those statements to this effect may be found in works of natural history. I cannot find one case which will bear investigation. Jake, you were gonna? Oh, okay. All right, so worker bees, insects of all sorts, they work without reproducing. They don't reproduce. Let's say a few things about the chart. This is the chart that comes at the end of the origin, in which he talks about divergence of character. And this is his so-called tree. And what we see here is he's speculating that this could be, these 14 levels could be 14,000 or 140,000 generations, lots and lots of generations. So the first thing that you get from this is that it's a vast period of time. This is, he's thinking of thousands and thousands of generations. And that's why evolution is hard for a lot of people to grasp, because they can't grasp the kind of time that Darwin is dealing with, the way in which he's thinking of change is spread out over hundreds of thousands and millions of years. Okay, so what you notice in this chart, well, what are the things you've observed from it? These are just the development of various forms, genera and species. What do you notice in this pattern? And the more ancient are at the bottom and the more recent are at the top. What does it tell you? Chris?
There's a lot of trial and error in terms of
Okay.
species trying to emerge.
Okay. Yeah.
Not every species now necessarily comes from the same common ancestor. There might be more than one seen in this picture.
Mm-hmm. Okay. Theoretically, if you go back far enough, you come back. But he's starting at some point here. We don't know. He doesn't have a specific time. Okay. Anything else? Yeah, Jake.
The speciation is getting faster as time goes on, it seems.
Okay.
Because at first there's like the two branches that break off. There's two of them, and then suddenly there's four on each side, and now there's however many you have at the end. It seems that there's getting more and more specialization faster and faster as the time progresses from the two kind of starting points into one.
Okay. So there's a kind of an advance in complexity and species diversity. What about F? E and F. What about E? What happened to E? Stayed the same? And? What's more? No longer exists. Sort of ended. So it got into the 10th stage of this, into the 140,000th generation, and it just, what did it get replaced by?
One of D's variants.
One of
A's variants.
A's pretty successful, isn't it? Look at A, how successful A has been. It's branched out into all these different areas. In successful species breed other successful species. This represents at one level physiological change. Well, from simple organisms, unicellular, and more complex organisms, and they begin to, organisms develop, primitive nervous systems and some photophores and things of that sort, and pretty soon, so it represents a kind of physiological spreading complexity, if you will. And those new physiology features enable organisms to branch out, doesn't it? I mean, make better use of environments, create new niches. So what you're seeing here is something like that. What else do these lines represent? They typically also are thought of in terms of strata, just layers, geological layers of the earth. I mean, if you dig down in the earth, you find earlier forms. And so, this is something that is reflected in this chart. The fact that, and most organisms, most species, by far, the vast number of species that have existed are gone. I mean, there are many, many more species have existed in time than exist now in terms of types.